All right, we'll try that again here. Okay, good afternoon. My name is Dan Kirshner. I'm the Executive Director of the Northwest Gas Association. I think probably most of you know me. We want to welcome you to the February edition of the Northwest Gas Association's monthly webinar series. We're pleased to welcome Jim Kobialko of FortisBC Energy to talk about the next generation of heating, gas-fired heat pumps in particular. We are recording this session, and just a couple of things to go over with you all as we enter in. And now there we go. Okay, we've got some upcoming webinars, including in March, an update on the status of natural gas in transportation. This will be a federal, regional, and local update. We're featuring the Natural Gas Vehicles of America Alliance and the Northwest Alliance for Clean Transportation, doing federal updates and state activity updates, and also some of the things that the Northwest Alliance has been up to. So we hope you'll join us for that. In April, we're still to be determined in our April webinar series. And then in May, a really important one for all of us, I think, to participate in, and that's the American Gas Association will be speaking about understanding the EPA inventory of greenhouse gas emissions and sinks. For those of you that aren't aware, the EPA releases this inventory every year, and every year the American Gas Association goes in and takes out the most salient points and puts it together into a nice presentation. It talks about what's the natural gas contribution to the inventory of greenhouse gas emissions, et cetera. So it's a really good presentation for all of you to listen into, and that'll be in May. With regard to today, all participants are muted today. Please use the chat function. I think you're all probably old hands at Zoom by now, so you know where that chat function is. Please use that chat function to ask questions, and I'll be monitoring that. I think our guest Jim will be monitoring that as well. If you have a question, I'll interrupt Jim to answer it, or if he happens to see it in midstream, he'll answer it himself. As I mentioned, our webinar is being recorded and will be posted to our YouTube channel probably later this afternoon. It takes a while to compile the videos usually. And Jim has graciously agreed to make his slides available. You can contact me for those slides, or I think Jim's probably going to have his contact info probably on the last slide of his deck. So without further ado, let me just tell you a little bit about who Jim is. I'm going to stop sharing while I do this and allow him to pick up the Slack there. So Jim Kobialko is a program manager for the innovative technologies and projects at FortisBC. For more than 10 years, Jim's been with FortisBC to evaluate new natural gas demand-side management technologies that could directly or indirectly result in significant reductions of energy use within FortisBC's service territory. What Jim enjoys most about his work is pushing the envelope of energy efficiency, driving innovation, and helping to support the reduction of BC's carbon footprint. Over his tenure, Jim has evaluated over 300 technologies, conducted 25 pilot projects, and transitioned 30 technologies for inclusion into full-scale rebate programs. So FortisBC, most of you know, good Northwest Gas Association member. It's a combined electric and gas utility serving more than 1 million customers across British Columbia, Canada. I think 900,000 or so of those, maybe even closer to 1 million, are gas customers in the lower mainland, and their electric customers tend to be in the inland area of British Columbia. So with that, Jim, go ahead and take away the screen. You should be able to get it by now.
All right, I think I'm sharing my screen.
There you are. Yes, you are.
All right, perfect. Thanks, Dan. Yeah, we are on the cusp of changing the way people have been heating their homes and businesses for hundreds of years. There has been natural gas technology breakthroughs that allow us to heat our homes at over 100% efficiency. Hello, everybody. My name is Jim Kobielko. I'm a program manager at FortisBC for innovative technologies and projects. I work within the conservation and energy management group, where we focus on DSM, demand side management, energy efficiency programs. And I focus primarily on conducting pilots and demonstration projects, basically looking at researching new technologies that potentially can save natural gas consumption, energy efficiency solutions. One of those being gas heat pumps, and that's the primary topic for today. So in today's presentation, I'm going to be painting a picture of the current landscape and emissions in BC. So what's the starting point? And painting a picture in terms of how does gas heat pumps fit into that? What role will it play? What is the market opportunity? What are some of the current information gaps for gas heat pumps? And then I'll kind of branch into some proof points. We conducted a pilot just last year on a gas heat pump where we have some results we can share with you guys, and showcase some of the other pilots we're currently underway. And lastly, I'm going to close with a call to action for folks on the phone to kind of gauge if you're interested in supporting. I'm going to provide some outlets and recommendations for you to assist. Okay, so kind of the 10,000 foot level, I always like to paint this picture when we're talking about emissions, because a lot of the benefits of gas heat pumps play a role in reducing emissions for the built environment. But just to provide some context, the built environment emissions represent about 11% of emissions in BC. There's about 64.5 million tons of CO2 emitted each year. And commercial customers represent 4%, residential represents 7%, and the rest is across transportation and industry. What I'm going to be doing today is I'm going to be focusing on just the built environment piece when we're looking at customers that heat their homes and businesses with natural gas and domestic hot water. So first off, I guess the key question, some of you may not know what a gas heat pump is. So what I wanted to do is take a quick step back and give a non-technical overview of a gas heat pump. And essentially what it does is it moves heat from the outside inside. And it's really similar to that of an electric heat pump because they extract heat from ambient exterior air. Instead of using electricity, the gas heat pumps combust natural gas to drive the compression cycle and transfer heat from the exterior air into buildings. Although they tend to have lower operating efficiencies compared to electric heat pumps, they keep operating costs low by avoiding a switch to a more expensive energy source. What is also very attractive with gas heat pumps is that they operate really well in cold climates, maintaining optimal efficiencies. Just to kind of paint a picture for you, in your homes, you might have a furnace, you might have a boiler, you may have kind of base efficiencies of that furnace say at 80%. I know minimum efficiency performance standards here in Canada for furnaces are 95% AFUE, annual fuel utilization efficiency, and that's a pretty high level of efficiency. And current furnaces and boilers cannot get past 100%. The only way to do it is actually with a heat pump technology. And what's really exciting with gas heat pumps is it allows to capture that energy or free heat from the outside in your homes to allow it to bridge the gap to exceed efficiencies greater than 100%. A lot of the technologies out there have COPs of greater than 1.1. I know Rober, which is one technology we're going to be profiling later on, has a nameplate value of 1.3. And some of the technologies we've come across have efficiencies up to 1.6 and greater, which is essentially 160%, 170% efficiencies. So when you're talking about emission reductions, and you're looking at your existing home and your furnace and boiler, you can basically swing from an 80% efficient furnace to, say, replacing with 160% efficient gas heat pump. That's a huge swing when it comes to improvements and reductions in emissions. So that's one of the reasons why we're really excited about this technology. But first, let's kind of paint a picture for you guys in terms of why else are gas heat pumps important? What are the drivers? Why are we looking at this today? Why is FortisBC investigating gas heat pumps? And some of you may know on the phone, if you're in Canada, others may not. But in across Canada, federally, there is a pan-Canadian framework that was issued stating aspirational goals, where by 2035, all space and water heating equipment must have efficiencies greater than 100%. And this is for both residential and commercial applications. It's for both space and water heating end uses. So one of the challenges I mentioned before, our current landscape of boilers and furnaces can't get us there. The only pathway is with gas heat pumps. Another piece that I wanted to emphasize at FortisBC, we also submitted 30 by 30, which is by 2030, our goal is to reduce 30% of our customers' emissions, and this is based on 2007 levels. We feel that gas heat pumps, among other pillars, as you know, there's other ways to reduce emissions. FortisBC is exploring RNG. We're looking at hydrogen injection and among many others. But gas heat pumps and energy efficiency play a key role in reducing our customers' emissions significantly by that tone of 30%. As I mentioned before, you're going from a swing of, say, 80% efficiency to 160% efficiency. You can totally get to the 30% reductions by 2030 by incorporating gas heat pumps. The biggest underpinning behind this good news story is the fact that the technology doesn't have availability here across North America. On the commercial side, if you're looking for larger heat pumps for, say, multi-unit residential buildings or schools, you can buy them for the most part right now. There's several engine-driven gas heat pumps out there. There's an absorption gas heat pump out there, the Rober, that you can actually purchase and install today. But for the residential side of the equation, that's, we have a significant number of residential customers in British Columbia. There isn't a solution. There are technologies that are in prototype phase, but there isn't any that's commercially available. You can't go to Home Depot. You can't, hire an installer and install a gas heat pump. So that's one of the key barriers, is the fact that the technology's not available. One thing I wanted to kind of paint a picture is there's also there's lots of movement in the place when it comes down to gas heat pump development. There's several manufacturers in North America that are currently developing prototypes. To name a few, there's Thermolift, there's SMTI, Stone Mountain Technology Institute in North America, where they're actually looking at prototyping a residential gas heat pump. I believe SMTI also has a heat pump targeting the commercial market. In Europe, we have in France Boost Heat, another residential gas heat pump that they're working on moving to North America and converting to the North American market. We also have Rober in Italy, who has the commercial heat pump that's already available, but they also have a K18 that is available in Italy that they're looking to also move to North America to fill the gap that we have. And lastly, there's many others. And lastly, there's Vicot in China, who has both. They manufacture both a commercial and a residential gas heat pump, and we're in discussions of ways to kind of bridge that gap to bring it over to North America and Canada.
So Jim,
so there's lots going on. Okay, sorry, go ahead.
Yeah, can I interrupt? This is Dan. So what I'm understanding you to say is these are commercial elsewhere, just not in North America. Are they widely deployed in Europe and Asia? That would be one question I would have. But they're being manufactured at scale, is that correct?
Well, I wouldn't say at scale. And so just to kind of answer your question, in North America, there aren't any. They have prototypes that they're looking at developing. In China, they have a commercial heat pump that's being manufactured at scale. I think over 20,000 units have been installed for commercial applications, but they're looking at developing a residential version, so that's not at that scale yet. In Rober, I think they have a handful of K18 models installed for residential, but it's not at the scale yet. Same with boost heat. So it's still in other countries they're getting to that point of scale, but it's not to the point where it's well known and recognized.
Okay, thank you for
Okay.
that. And I just want to remind our listeners and watchers that if you use the chat function down at the bottom of your screen to ask any questions you might have of Jim as he goes through his deck. Thanks, Jim.
No worries. Okay, so let's kind of shift to market barriers. I kind of painted a picture that, hey, there's a fantastic opportunity, reducing GHGs, supporting FortisBC's 30 by 30. There's definitely a lot of benefits on that end to switch from an 80% efficient furnace to say a 160% gas heat pump. But the question is, how do we get to the point of commercialization? Why are there manufacturers out there that are having challenges scaling this technology? And it really comes down to really the 5 A's. When you look at availability, accessibility, awareness, affordability, and acceptance, the first barrier is the availability of the product. And when you're speaking with OEMs and manufacturers, it's a little bit of a cat and mouse discussion where they want to make sure that there's a demand before they develop the solution. And from a utility perspective is we want to make sure there is a solution before we provide rebates to drive the demand. So it's a little bit of a back and forth discussion. And one of the things that I'll talk a little bit later on is in terms of an opportunity for folks on the phone is we can come together to kind of pool our resources and have one voice to these OEMs to help support their business case to invest in bringing this technology over to North America. Obviously, the accessibility and awareness and affordability and acceptance all kind of linked to having a technology available. On the awareness side, and this is something we noticed here in BC, the technology was available. I believe Rober had a gas heat pump that was available for installation in our service territory for several years, but there wasn't any installed. So we're wondering why? Why is that the case? And we found out that there's just a lack of education with industry and trades and contractors. There actually wasn't a distributor set up that causes issues. If you wanted to purchase some equipment across the border, you have to deal with brokerage and customs, and that causes a barrier. It ultimately just wasn't, the word wasn't out there. So that's a huge barrier that we need to bridge. And as a utility, we're in a unique position where we can help bridge that gap of awareness. We have bill inserts. We're continually touching our customers in terms of messages and sharing with them rebates. There's definitely an awesome opportunity for the utility to play a key role in driving that education. Affordability, again, when you're dealing with a technology that's not at scale, you're actually paying a lot more per unit for that technology. So it is actually more expensive than other alternative solutions. But in speaking with manufacturers and OEMs, they feel that if you do get scale, they can actually bring the price down to more of a comparable market with those alternatives. And lastly, acceptance. That's, we don't know if customers accept until they actually install it. And we have some interesting results on all of these 5 A's from conducting the actual pilot itself that I'll share shortly. Okay, so let's go to the next piece here. What I wanted to do is kind of map out a timeline that shows what FortisBC has done, and actually our evolution on the gas heat pump side started way back in 2015. we are looking at gas heat pump solutions. We're looking at energy efficiency opportunities, and me being an innovative technology program manager, that's my job, is to investigate these. And I was wondering, wow, there's gas heat pumps. No one's looking at gas heat pumps. There's none being installed. Let's find out a little bit more. So we conducted a pre-feasibility study to identify what's out there, what is the potential for savings in our service territory across our customer base, what are the barriers to adoption, and how can we fill those gaps. And we identified that there's actually quite a significant savings opportunity, around 500,000 gigajoules that can be saved per year by adopting gas heat pumps. And there were some technology solutions out there that you can purchase today. So what Fortis decided to do is we decided to design a pilot program targeting one of those technologies that was available. That was the Rober GAHP-A model. So we did in 2019. We were the first. We supported the first installation of a gas heat pump, gas absorption heat pump in BC. And actually across Canada, I think there were only a few also installed in Ontario through Toronto Atmospheric Fund in support with Enbridge. But other than that, it's just a handful of installations here in Canada. So we're really leading the charge on this pilot, installing it. Also in 2019, we worked with GTI as well as other utilities that were also very interested and aligned with the need of gas heat pump adoption. And we conducted a market transformation roadmap to really break out what are the gaps, how can we support it, what can we do as utilities to really drive the adoption. And if you folks are interested to finding out more about that roadmap, we've developed a white paper that we can share with everyone that's interested. Also in 2019, we formed the North American Collaborative. I think there's over 14 members now, and it's all about discussing ways we can drive the adoption of the gas heat pump market for the commercial side, the residential side, for space heating, for domestic hot waters, water heating, etc. And also in 2019, we got our first distributor set up in BC, which was critical. So you can do all these pilots and demonstration projects, but you can't really launch it into a program if customers can't get their hands on it.
Jim, let me just interrupt for a minute. I just want to acknowledge there is a question in the chat. Where's the gas heat pump in BC installed? And a FortisBC RAV responded to that question saying they're all installed within the Lower Mainland or Vancouver area. So just wanted the group to know that question was out there. Thank you.
Absolutely. And thank you, Rav, for responding to the question on the chat. And yeah, I do have slides talking about specifically the pilot later on, but we installed it on 7 different buildings, and we had 2 Rober units per site. So there was a total of 14 that was installed. So in 2020, we're just last year, we got the results of the pilot that I'll talk to you about a little bit later. We also are working with NRCan, a roadmap market experts group that was formed. I'm part of that group, where we also work together to see what we can do to bridge barriers through testing, through pilots, through what can we do to really drive the adoption. And also we launched another pilot targeting residential this time with Thermolift that's doing a prototype. In
Jim,
go ahead.
Jim, you referenced NRCan. Can you explain for the audience what NRCan is?
Natural Resources Canada. So one of the key mandates that they have is they publish the Pan-Canadian framework, aspirational goals, which basically looks at equipment efficiency for appliances. And by 2035, that equipment efficiency, as I mentioned earlier, must aspirational goals to increase to over 100% by 2035. So they're the ones that kind of drove that and planted that seed, and we're also on the board to support it and see what we can do to help achieve it.
Yeah, so just for the benefit of the group, and I might be getting this wrong, but I think I'm right. NRCan, Natural Resources Canada, is sort of a mashup of the U.S. Department of Energy and the U.S. Department of the Interior, kind of like it's got little pieces of both of those in it, right?
Comparable, yeah. If you're going to compare it and to relate how that's formed, that would be a good characterization. Okay. All right. So 2021, this year, there's actually a lot going on. We're working towards installing the first ever across North America, the residential gas absorption heat pump. This is the Thermalift product. So we're really excited about breaking ground. We're hoping for Q3 or Q4 of this year of installing the system. And we're also bridged off of our commercial pilot with the Rober that focused on domestic hot water. We're looking at converting that to support space heating demands in the building. So there's still a lot of questions that we have for this year on gas heat pumps. We wanted to see whether we can get the savings there. I think Thermalift claims efficiency or COPs of 1.6. One of the key benefits of doing a pilot from a utility perspective, and that is not biased and technology agnostic, is we can evaluate the technology, install monitoring equipment, and actually see where the efficiencies are. What are the barriers? What are the challenges that we need to consider if we were to launch a full-scale rebate program? And that kind of leads into 2025. If you follow along the timeline here, that's when we're hoping to have larger scale rebate programs, have a offering that's available for customers, not just from one manufacturer, but multiple manufacturers providing solutions for residential. And in 2030, it's all about seeing what we can do to help support driving the adoption, education, awareness, and support with the acceptance, and help drive our 30 by 30 targets. And then by 2035, hopefully we can get to the point where we can hit that pan-Canadian framework aspirational goals while we provide customers with a solution where they can install gas equipment that has efficiencies greater than 100%.
So Jim, one question here. Again, I'm the one asking questions here, but I hope that's okay.
That's totally fine.
How are you, or is FortisBC working with its neighbors to the south? So Northwest Energy Efficiency Alliance and others. Clearly,
Absolutely.
market transformation is a bigger lift than one jurisdiction, right?
Absolutely. Really good question. I'm glad you brought it up, because I actually do have a slide coming up talking about collaboration opportunities. We recognize that manufacturers are not limited to only serving BC. Their market is a lot larger than BC. And we also recognize that gas heat pump interest is not isolated to BC. So part of the North American Collaborative that I mentioned earlier, I believe Northwest Natural is a member there. SoCal Gas, I think we have several other utilities that are on the phone that are members. And the whole point is to share information, collaborate, fill information gaps. We might need to do some studies, reports. We may need to do a field demonstration project and share costs. So it's definitely a key opportunity for us to work together, because the challenges that we face here in BC are not isolated to BC. And to drive the adoption of gas heat pumps, this is a North American opportunity that we need to face in collaboration with other utilities. So there's opportunities through the North American Collaborative. There's opportunities through in Canada to being part of the NRCan Roadmap Market Experts Group. There's also lots of other industry associations and groups. The Gas Technology Institute is a great resource. There's a consortium for energy efficiency that you can take advantage of. They have groups focused on gas heat pumps, as well as Energy Solutions Center. There's many other industry experts out there that you can then collaborate. But we do feel that it takes a village, and we need to work together. All right, hopefully that answers your question, Dan.
Thank you.
All right, perfect. Okay, so Now I'm going to shift gears in terms of providing you a little bit more on the pilot results with respect to the rover. And keep in mind, the nameplate value of the rover GAHP-A model is 1.3 COP. So essentially, the nameplate value shows that this system can operate at 130% efficiencies. We measured the results on, as I mentioned earlier, 7 sites, 14 units, and we got an aggregate average COP of 1.14, which is still fantastic because it's over 100%. And we actually had periods of time that was measured in the pilot where the temperature was extremely cold. We had minus 10 degrees Celsius or 14 degrees Fahrenheit temperatures in the pilot, and it still performed at efficiencies greater than 100%. So some good learnings, but we also identified opportunities to improve the pilot as well. And just to kind of give you a visual here, the top line there is the before. We took some photos of the before the installation, and the bottom shows the after. As you can see on the top, there's the existing domestic hot water boilers. We had the existing domestic hot water storage tank that we actually leveraged as a backup. And then we had the location, which is on the roof. For the most part, the majority of all of our sites had to crane the units to the roof. And that's part of the reason for that need is the width of the modules of the gas absorption heat pump was, I believe, 2 inches too wide to fit in the service elevators. So we need to crane it. So one of the suggestions that we provided to Rover is, you know what, you can cut down a lot of costs if you were to reduce the width of the modules by just, you know, 1 inch or 2 inches. Then you can reduce the costs of craning. And the craning was what, $5,000 to $8,000 just to crane them to the roof. We had to close the street. We had police escorts. It was a big deal.
So
So
Jim,
if we're able to simplify that by reducing the width, then you reduce a lot of costs. Go ahead, Dan.
we do have a question here. Has FortisBC encountered any building code changes, either enacted or proposed, that would support or impede a gas heat pump installation or use?
I'd say I haven't come across of any building codes that would impede it. I know the Rover unit meets the ANSI 21.1.40. I think Rav, if you can kind of just put in the levels there, but it meets the current standards for install. But I don't know of any level of limitations that prevent the install of the system. All right, and on the bottom side.
Sorry, Jim. I just wanted to let people know, check your chat box. So Rav did put the ANSI reference in the chat box for you.
Thanks, Rav.
Sorry.
And just so you know, Rav was one of the engineers that worked with us to support the M&V side and the evaluation of the pilot. So thanks for filling in the gaps there, Rav. And the bottom line, as you can see, there's a prefabricated package in the penthouse mechanical room. What we did there is we recognize that when you install a gas heat pump, typically you think of just, hey, you install the gas heat pump and you walk away. That's not the reality. In reality, there's a lot of companion pieces that you need to install in conjunction with the Rover unit. You need a buffer tank, you need an expansion valve, you need controls, Grundfos controls, you need a place for a filling station. So there's a lot of things that you need to incorporate. So one thing we wanted to do when we conducted this pilot is we wanted to have sites that are comparable to one another. So we designed this skid package that where you can kind of just fit all these companion pieces in place, and the install is going to be the same across all sites. And as I mentioned earlier, we had to crane it onto the roofs, and the bottom right is the actual installation of the unit. All right, so this will talk a little bit about the overall savings, and I'll just kind of navigate this chart for you guys based on the blue and red dots. We typically, the designed pilot focused on the red, which is 2 gas absorption heat pumps. And what was interesting is when we installed them, we found that the overall efficiencies of the 2 gas absorption heat pumps was not hitting the levels that we thought it should. And we found that right sizing the units was a critical learning. So we basically treated every site the same. So we installed 2 GAHP units per site across 7 sites, but every single building had a varying level of demand. And if you were to size the GAHP unit differently, you would get better efficiencies as an outcome. So what we decided to do is play around with, hey, for some of those buildings that didn't require 2 gas absorption heat pumps, what if you had 1? And we actually found that the COPs and the overall efficiencies increased significantly. And also what we wanted to do is we worked with our implementation contractor to say if it was right sized, would that improve the overall savings? And it did. So in terms of learnings, I mentioned earlier, the pilot resulted in efficiencies and COPs aggregate level of 1.14. We had a fantastic customer acceptance. So we surveyed the building owner as well and asked them, what any experience, any issues, and they give it 2 thumbs up across the board. We also surveyed the contractors to gauge what their experience was installing it. Initially, their initial perception was they were concerned about ammonia refrigerant. They're concerned about the installation on the roof. They didn't know about the maintenance. They had a lot of reservations and concerns. After the installation, there weren't concerns about ammonia condensate. All respondents were satisfied with the installation. They recommended actually the unit to other sites. A lot of it was plug and play. And they mentioned it was really no different than installing a condensing boiler. So that was really encouraging feedback to get from our installation group. And also cost effectiveness. Again, this unit was relatively expensive compared to alternatives, but we ran different sensitivities to look at ways to optimize it. So if it was right sized, you might not need to have multiple modules. If you had a backup a boiler installed to cover kind of the peak periods of the heating season, then you don't need to have a lot of different systems installed. That reduces costs. If you're able to reduce the width of the gas heat pump, you can fit in service elevators and you don't have to experience the costs of the craning. So there's lots of ways we can drive the cost effectiveness of this system itself. All right, so now shifting over to next steps, the pilot, where it led us and where we're going now. There's still some questions about, if we were to install a tankless water heater instead of a boiler to see whether there wouldn't be short cycling. One thing I noted is the nameplate value of the gas heat pump was 1.3. The COP from the pilot was 1.14. So there was a reduction in overall efficiencies. One of the things we noticed was the backup boiler was starting to short cycle. If we were to install a tankless condensing water heater, then that would solve the problem and better control. So we're looking at assessing that with installing a tankless condensing. We're also looking at installing the gas heat pump for space heating applications. The pilot was only on domestic hot water. And just to quickly, I think, Dan, I probably have about 6 minutes and then I'll go back to you. Is that right?
I think we're doing okay right now. We're able to entertain questions as they're coming up here,
Perfect.
Jim. So let's flow on.
So I just have a couple more slides. What I wanted to kind of show you is what FortisBC's plans are also in the mix for this year. I mentioned earlier is we're looking at installing the Thermalift residential heat pump. That is a pilot where we're going to be installing it into 10 residential customer homes. We've slated it for Q3 2021. Initially, it was earlier this year, but due to COVID and some of those challenges, we had to kind of push it out a little bit more. But we're still hopeful that we can install it for this year. And we're also looking at initiating the M&B once we install the system for over a year to then compare efficiency. We're going to be measuring customer acceptance. We're also going to be measuring installation challenges. But we're really excited about this technology. We feel that this will be a disruptive gas appliance that customers can install. In speaking with the OEM, even though the costs are relatively expensive on the prototype phase, they feel that they can get the cost with scaled down to a comparable level. And if we can showcase the efficiencies that they claim, this could be a really interesting program that we can provide rebates on in the future. Another pilot that we're currently working
Jim, quick question. Sorry to interrupt. This is always the awkward part of this, but what's the market share for boilers in BC? For us in the States, it's only about 6% for the existing market. That's one question. The other question I had was a clarification really on what you just said. The manufacturer, Thermalift, thinks they can, beyond the prototype, get that comparable to what was the comparison?
Electric heat pumps.
Okay. All right.
Yeah. And sorry, I don't have the answer on the boiler side.
Okay.
I don't know if folks on the phone, they have the answer from Fortis. If you can respond there. If not, we can take that offline. And the next pilot that we're currently working on, and this is partnering for progress with other utilities across North America. So this is a project in conjunction with and through the Gas Technology Institute with I believe there are 6 other utilities where we're installing 61 water heater gas heat pumps across North America. As you can see, we kind of plotted on the chart the locations of those utilities. And I believe this is a Renai water heater. That's a gas heat pump, and they're claiming COPs of 1.4. We're hoping to also install these units this year and get results in Q1 of 2023. So I think at the end of the day, I wanted to kind of paint a picture of, there's a huge opportunity for gas heat pumps. There's a lot of opportunity to reduce emissions, but it's not without challenges. There's a lot of barriers to prevent the adoption of this technology, but to add the caveat, there's a lot of utilities that are on board to support this and industry actors. There's a lot of pilots underway. A lot of manufacturers are investing in this technology, and it's not just limited to North America, it's across the world. So a couple of things I want to mention is provide you a call to action. If you're interested in supporting gas heat pump initiatives and help supporting the transformation of this technology in your service territory, there's lots of ways you can help out. As I mentioned earlier, you can link up with industry working groups, the collaborative, North American Collaborative. You can participate in different industry associations like CEE, Energy Solutions Center, GTI. If you need a link to them, I'd be more than happy to introduce you guys to them. Also, on the commercial side, there's really nothing stopping us to have a commercial incentive program for gas heat pumps. You have them available, they can be installed, it meets current standards. You can work on developing an incentive program at the same time of maybe considering to support pilot demonstrations on the residential side. And lastly, if that's something you can start working on your DSM planning cycle, maybe you can put some provisions in your budget to account for some budget support for gas heat pumps. We'll need to look at doing some awareness campaigns, promoting programs, and those types of efforts. And the last plug here is, if you guys are located in BC, if there's folks on the phones that are interested in being part of future pilots, please check out fortisbc.com/let's go. It's a little form there that you can fill out and basically state your interest in being a pilot. And as we're looking at doing new pilots in our service territory, we could consider you being a prospect. And with that, that concludes the presentation. And I'm just going to grab some quick water here.
Yeah, you're getting running dry there. So Puget Sound Energy says they'd appreciate the links. Can you provide links to some of the resources you just discussed? And we can get them out to the group. We've got a distribution list. And then from Northwest Natural, it's important to note that the primary focus of the North American Gas Heat Pump Collaborative is on residential technology. So that's a good reminder, John. Thank you for that. Any other questions that we have for Jim? I'll give you just a minute to type questions in if you have. Just a reminder, our March 18th webinar will be an update on the state of natural gas vehicles, natural gas and transportation. And then we've got one in May that is an update on the EPA inventory of greenhouse gas emissions and sinks by American Gas Association. And we're busily working on, I'll tell you what we're aiming for in April, and that's a presentation on the American Gas Foundation's recently released report on the resiliency of an integrated energy system. So focusing on natural gas contribution to a resilient energy system. So hopefully you find those compelling topics. And I am not seeing any additional questions in the chat, Jim. So I think you've answered every question. And we appreciate your time today. Just a reminder to the group, if you're interested, we did record this presentation and we'll be posting it to our YouTube web channel later today. You see Jim Kobialko's contact info there. Feel free to contact either me or Jim to get the slide deck directly if you're interested. I'm sure Jim would be happy to talk to you further offline, and folks that Jim works with as well if you have additional questions. So thank you, Jim. As we encounter a difficult policy environment with regard to natural gas up here in the Northwest, it's really gratifying to see that there are technologies coming to the fore that can help address some of the concerns that are attempting to be addressed by what we consider misguided policy direction. So that's my editorial comment for the day. Thank you, everybody. And I wish you a great rest of your Thursday. And thank you, Jim.
Thanks, everybody.